Hello everyone, this is Vikram and welcome to my channel AIML Made Easy. In this video, we are going to understand one of the most common and most confusing topics in AIML foundations, which is the difference between AI, ML, DL and Generative AI. A lot of people use these terms interchangeably, but they are not the same thing. They are related, they are built on each other, but each one has something different. By the end of this video, you will clearly understand what AI is, how machine learning fits inside AI, how deep learning fits inside machine learning, and where generative AI fits into this larger picture. So let's get into it. So here is what we are going to cover today. We'll talk about AI, ML, DL and generative AI. We'll break down each one, understand the hierarchy and see where each one fits in the bigger picture. But before we jump into the definitions, let's get some context on why this even matters right now. Today, AI is part of everyday conversations. We use tools like ChatGPT, Cloud, Copilot are being used across industries and workflows. There is even this concept of vibe coding, where developers are building full applications with minimal effort just by describing what they want in natural language to these AI models. What really changed is that AI is no longer abstract. It is part of our daily workflows, from writing code to debugging it to making decisions or for creating end-to-end CI/CD pipelines. So AI is everywhere. And more importantly, this is not just automation anymore, it is augmentation. So which means we are directly collaborating with AI as thought partners and co-developers. So understanding AI today is not about understanding the theory behind it. It is about building the right mental model so you can use these AI tools effectively. Think about how software development looked even 6 months ago. Building a service or an application means writing boilerplate code from scratch. Of course, we have various build tools that can generate the boilerplate code, but still, like, it's a manual effort, like writing the source code, debugging it manually, and reading the documentation for us, for writing a perfect code. But today, developers are vibe coding full applications. They can use or they are using Cloud Code or Copilot or Codex CLI to code in real time and use these models for explaining complex failures or creating end-to-end workflows. This can be a testing workflow, it can be a CI/CD workflow, it can be anything. So we are no longer just coding, we are collaborating with AI with for all these things. And for those who are new to this term, vibe coding is a software development approach where you build applications primarily through natural language conversations with AI. So you just ask AI what exactly you need and how you want to structure the entire source code. So AI would take this information and write the entire source code for you. So what actually changed? AI became context aware, capable of reasoning, and more importantly, it is embedded into the tools that we use, like the VS Code and any other IDEs. So AI tools can be easily integrated into these tools. For example, ChatGPT and Cloud Code help in problem solving, and Copilot can be used for coding. AI assistants in ID give real-time support as well. And if you think about where you're already using AI, so we are already using AI for vibe coding or creating documentation, explaining the code, building some automations in Python or any other language, debugging infrastructure related issues, or understanding the logs, generating Terraform configurations, because I'm from DevOps background. So basically I use AI for creating the configurations or creating modules or writing the Jenkins files, or it can be anything. So you can see the growing ecosystem of AI tools like Cursor, Llama, Cloud Code, Tab9, Replit. So there are many AI tools, and this list is growing. So the point is, AI is not something coming in the future. So it is already there and it is embedded in our daily tools that we use. Let's jump into what is AI. So artificial intelligence refers to the ability of computer systems to perform tasks that typically require human intelligence. Things like the learning, problem solving, reasoning, and decision making. AI is umbrella term, so it's a big term, and it covers a wide range of technologies and approaches that enables machines to mimic human like thinking or human cognitive functions. AI systems can learn from the data which is machine learning part basically. So they can reason and make decisions once the training part is completed. They can understand natural language and they can perceive the environment through sensors, vision, and audio. Now, if you look at this diagram, you can see how machine learning, deep learning, and natural language processing, large language models, and conversational AI all are inside AI, and how these are interrelated to each other. So these are all subsets. Each has a different focus and different level of complexity. So the way to think about is, consider AI as a medicine. So under medicine we have different specialties or departments like cardiology, neurology, orthopedics. They're all under medicine, but they specialize in very different things. Similarly, ML, DL, and GenAI are specialized branches within AI, each with different scope and different complexity. The AI can be categorized into three based on their capabilities. The first one is artificial narrow intelligence, or ANI. So this is AI built for specific tasks like spam filtering, recommendations, facial recognition, medical image analysis. These systems excel at only one job because they are trained in such a way that they perform better at only one job. But if you try to use it for anything outside of it, it may not perform well. For example, ANI that is specially designed for spam filtering cannot suddenly start recommending movies for you. Most of these AI systems that we interact with today, like email, spam filtering, fraud scoring, recommendation engines, all of these are narrow AI because they excel at doing one thing. The second is artificial general intelligence, or AGI. This refers to a machine that can think, reason, and learn across domains the way humans do, handling new situations without being specially trained for each one. AGI would bring together creativity, initiation, and common sense in a single system. People sometimes refer tools like ChatGPT or Cloud Code or Gemini in AGI discussions, but whether we are actually close to true AGI is still very debated. What we have today is impressive, but it is not the same as genuine general intelligence. The third is artificial superintelligence, or ASI. This is hypothetical form of AI that would surpass human intelligence across every domain like science, creativity, strategy, reasoning. It would learn and self-improve at a pace no human could match. ASI doesn't exist today. It is still a theoretical concept. Now let's understand what is machine learning. So machine learning is a subset of AI we have seen in the diagram. It is a subset of AI that enables systems or machines to learn patterns from the data and improve over time. In traditional programming, what we usually do is we write explicit rules like if else conditions, that if this condition is met, do this. In machine learning, instead of writing those rules, we give the system a bunch of examples and the system will figure out the patterns on its own. So the system, if you take the case of like the whole process in the machine learning, what we do is we feed the system with the data, and then machine will try to analyze the data and understand the patterns from that data. And if you ask it something new, it is going to answer it by predicting the response. For example, Netflix recommends movies by learning from a user's viewing history and identifying similar patterns across millions of other users, like what other users are watching. Nobody manually programmed these recommendation systems. These systems learned these from the data that they have. For example, like Amazon's personalized shopping recommendation work the same way. So if you look at the machine learning process, it is following the same thing, right? So from the data collection, you feed the data to the model. For feeding, again, you have to collect it, clean the data, and prepare the data in such a way that that data can be used to train the model. And once the model is trained, you can test and evaluate with test data. And once it is evaluated, you can deploy the model and keep monitoring it, and you keep repeating the cycle. So this whole process is nothing but machine learning operations, or MLOps. Now a simple way to remember ML is it is kind of a program that has learned patterns from the data that we have used during training. And what this model does is this model uses these patterns to make predictions on the new and unseen data. Now coming to the types of machine learning, there are 5 different types, even there are more. The first one is supervised learning. In supervised learning, the model is trained using the labeled data. So which means, you have the input and you also know what is the type of the output. So for example, you feed the data in such a way that you tell the model that this is a rectangle, this is a triangle, and pentagon, hexagon, and all. So when you feed the data, so the model knows what exactly is that data. So one of the main tasks, there are many tasks. The main 2 tasks in supervised learning are classification. That is, once the data is once the model is trained, and if you give the unknown or new input to this particular model, it will generate the output. So the one such output is classification, where the model will try to decide whether it is this shape or this shape, or whether it is a spam or not spam. So it is kind of true or false, or it is kind of having like 2 values. So this is classification, like you classify whether it is spam, not spam, it is good or it is bad. But it can also do regression. So regression is kind of having predicting a value or a continuous value. For example, let's say I trained a model to predict the house prices, but during the training process I fed multiple inputs. Each has different features, like the number of rooms, the locality, and all those things. So based on that input, I've trained the model. Now if I ask the model to get me the price of a house with these many rooms and this locality, so even though that particular information is not available during the training process, what model will do is it will answer the question by using the learned patterns during the training process. So the regression will give you a value. So it is not either 0 or 1 or true or false. So it can be any value between 0 to infinite, right? So that's a continuous value. So this is what the classification is. For example, during the training process, I have given input as well as labels. For example, let's say if the text contains win a free iPhone, the text also has these exclamation marks and weird emojis and all. So what I can do is I can just label it as spam. And for example, meeting at 3 p.m. so I marked it as not spam. So during the training process, I'll feed the model with hundreds of such examples. And what model does is model will learn the patterns. And when a new email comes, based on the learned patterns, it can decide whether it is a spam or it is a not spam. So this is a classic example of classification. The other example is unsupervised learning. So here the model works with unlabeled data. So I feed the model with data, but I will not say what sort of data. So in this case, what model does is the model will find hidden patterns, since it cannot decide whether it is spam or not spam because it is not a classification. So what it does is it forms clusters of similar data or structure. So by utilizing the structures in the data, it can form these sort of clusters. Think about customer segmentation, right? So you give the model data about user behavior, purchase history, and demographics without being told what the groups should be, right? So I won't say the person belongs to this reason and all. So what model does is model will identify patterns naturally, and it will form the clusters. So it will form the clusters of similar users based on some learned patterns. So common tasks in unsupervised learning are clustering, which is it will form the clusters because the model doesn't know the labels, so it is fed with unlabeled data, right? Now other type of machine learning is reinforcement learning. In this, a system learns by trying actions and receiving feedback in the form of rewards and penalties. So what it does is, so the model will predict the answer, So if the answer is correct, it will be rewarded. If the answer is wrong, it will be penalized. So over time, it figures out which actions can lead to best outcomes. It is essentially trial and error and getting the feedback. A good example of reinforcement learning is a self-driving car learning to park. It gets a reward for parking correctly and a penalty for making mistakes like bumping into other obstacles or not parking well. So through thousands of trials, it learns the right approach. Now there is another extensions. It's an important extension to reinforcement learning called reinforcement learning from human feedback. So in this technique, a model is trained using the human feedback instead of just raw data. So instead of a reward coming from an automated system, actual humans will guide the model by giving the feedback like rewards or penalties. For example, let's say in case if you have used ChatGPT extensively, sometimes when you ask ChatGPT for some questions, so it might generate two different types of answers, and it might have asked you to select the proper one, like or select the most impressive one. So this way, what ChatGPT will do is ChatGPT will tune its responses from next time based on the user's preferences. There are other types of machine learning as well. The other one is self-supervised learning. So this is important in modern AI systems because it is how most of the LLMs are trained. So if you're new to LLMs, we have some foundation topics coming in the next video. So the idea is the model creates its own labels, okay, from the input data. So you take an input and you mask or remove a part of it and ask the model to predict what is missing. For example, take a sentence, you just hide a word or a part of the sentence. Now the model learns to predict the missing word. So do this billions of times across massive amounts of text, and model builds a deep understanding of language, the context and patterns. So the reason this works so well is that you do not need humans to label anything. So you feed large amount of unlabeled data and the model will try to understand the patterns, like get the context, everything from that unlabeled data during the training process. So this is how large language models these days work, right? Like LLMs like ChatGPT and Cloud rely heavily on self-supervised learning. Secondly, semi-supervised learning. This uses a mix of labeled and unlabeled data. So the model first is trained on the labeled data. So it learns from that labeled examples and try to get a deeper understanding by forming a deeper understanding of that data. Now when you ask it some question, it is gonna answer it based on the learned patterns. A good example is medical imaging. Imagine a hospital has thousands of x-rays, right? But only 500 or some certain number of x-rays are reviewed by radiologists. So the model trains on first 500 labeled scans and then applies what it learns to the remaining data. So it is a practical approach where labeling the data at scale is expensive or impractical. So this is a summary of all the machine learning types. Now let's understand what is deep learning. So deep learning is a specialized branch of machine learning that uses artificial neural networks with many layers to learn patterns from the data. So you can see the difference between, or the comparison between, the biological neuron and the artificial neural network that we have. For example, Facebook's facial recognition. It uses deep learning to recognize faces in the photos, because when we upload photos, we also have this habit of naming those photos. The model gets trained on millions of labeled photos, and learns to identify faces in these uploaded images. Okay, so now when you upload a photo which is not there before, so the model can predict the name of the person in that photo because of the deep learning. Okay, so if you look at the neural network diagram on the right side here, so the data comes into the neural network and it reaches the input layer. So the input layer can be anything, like it can be image, it can be text, or it can be a video. For example, for text it can be tokens, for images it can be pixel values. It then passes through multiple hidden layers, right, where neural network progressively learns and understands complex features. So the first layer might detect the edges, or the second layer might detect the shapes, and internally it will have thousands of layers to actually recognize the object. So finally the output layer can give you the prediction. For example, like you give this input and model will predict that this is a cat. Okay, it's not dog or bird because of the learned patterns. Okay, so the way it actually works is, if you try to compare it with the human neurons. Okay, so it can be compared with human neurons. So there is a function which decides whether a particular neuron should fire or not fire. Okay, so if you look at the previous example, like we have the inputs. Okay, so these are the inputs like x1, x2, and x3 and xn, and then there are weights associated with these inputs, and then there is a bias value as well. So the output of the activation function can be w1 x1. So if you add all of these, and then if you add a bias, this becomes the output. So this is an activation function which decides whether a particular neuron should fire, or how strongly it should fire. Each neuron will take an input and applies weight, and then it will now add bias, and then it is passed to the activation function, so which will decide whether the particular neuron should be activated or not activated. For example, let's say during the training process, initially we'll start with some random weights. For example, w1, w2, w3 will start with random, and then the bias will also be a random value. So if you feed it with cat during the training process, what will happen is, since we know that this is a cat, so in order to get this particular value, so all the weights, internal weights should be adjusted. So do this millions of times in order to get the perfect weights. So now when you give a different type of animal as an input, due to based on the different layers, so a particular neuron will get fired and the others may not fire. So based on that, you will get the final output. It can be complex, but this is how the neural networks internally works. Now coming into the generative AI, this is the last one. So generative AI, everything we have discussed so far, machine learning, deep learning, these are primarily about analyzing the data, recognizing patterns, and making decisions or making predictions. But generative AI is something different. So instead of analyzing the existing content, it creates new content. Okay, it can be a text, it can be image, it can be code, it can be audio, video files that doesn't exist before. It does this by training. It does this by learning patterns from the massive amount of existing data using deep learning models. Okay, we have seen already that there is a training process involved for these models with millions of data. So during this training process, it learns those patterns. So now when you ask it a question, it is going to generate a new response which was not existing before. Now when most people think of generative AI, they think of ChatGPT, but GenAI is broader than just text, because ChatGPT we usually use for generating text. Of course, it can be used for other media types as well. LLMs like ChatGPT, Cloud are text generating subset of GenAI. Okay, because we generally use GPTs and Clouds for text generation. But GenAI is broader, so it can also include image generation models like Stable Diffusion, or audio generation models like 11 Labs, and video generation models like Sora or Runway. Okay, so it's not about only text. GenAI can be other types of data as well. So this is how generative AI work. The neural networks learn from the massive data sets that we use during the training process, and when you ask it a question which was not part of the training, So based on the learned patterns, it can give you the response. So the response can be text or image or music, or it can be a simple design file as well. Right. Okay, so that's it for this video. In the next video, we'll talk about foundation topics for AI ML. Basically, we'll understand various terminology that we use in AI ML, like what are LLMs, what are tokens, what is an MLOps, what is a RAG. So there are many terms that we need to understand before deep diving into AI ML topics. So if this video helped you, hit that like button and subscribe to AIMLMadeEasy YouTube channel. Thanks for watching.